Are you in your notes at this spot? Are we ready to go? Okay. We have the following information. It says solve the following triangles and begin by classifying which of the 5 cases it will be. And we're going to show you what that looks like. We're going to actually work backwards in the notes a little bit. Again, I'm not going to give you the assignment today. We're going to have the assignment on Monday. And we're going to catch some people up. But this is going to hopefully provide a solid foundation for you. I have a triangle, side A, or angle A, angle B, and angle C. I want to be able to find all the parts of that triangle. So I label A, B, C, little a, little b, little c. A is 42 degrees. I'm going to mark that right here. All right. Do we know this side? Do we know this side? What is it? 22. So I put 22 for A. Do we know this side? 12. At this point, I have to look at my decision tree. Please make sure that you have out that decision tree that can help you know what you should do. Yep, you might want to rip it off the back. This is, again, what you get to use on your test. I will reference back and forth between this. Can somebody tell me, anybody out there, out of the 6 different kinds of triangles that I have, which kind of triangle is this? It is a side-side angle. I have 2 sides and I have an angle that doesn't sit between them. So I have side-side angle. Backwards spells donkey, right? So I go here. Everybody located here? I move down and it then says I have to decide, is the side opposite the angle longer than the other given side, or the side opposite the angle shorter than the other given side? So I look at this and I look at the side opposite the angle. Is 22 longer or shorter than 12? It is longer. So that tells me what to do. It's very clear. It says it is longer, use the law of signs, and I just get one solution. Everything is good right here. So let's do it. Law of signs. Set it up. Sine of what? 42 over what? 22 equals? Very good. It's got to be angle B because B is across from 12. I cross multiply. If I simply just, and I want to be clear here, Gavin, if you actually just multiply both sides by 12, 12 sine of 42 over 22 is equal to the sine of B. So I don't even have to multiply the 22 over, just multiply the 12 over, I get that guy. And I take out my handy dandy calculator. You know, I didn't do MySpace, so I didn't do it. So 12 sine of 42, and I divide that by 22 equals, oh, thank you, good job, way to catch that. Mode, yep, I exactly just came out of calc, that's what happens, so. Take that same entry, 0.36498 is equal to the sine of B. Can somebody tell me, is sine able to be a value of 0.3? Think about the sine graph. What's the biggest spot that the sine graph reaches? 1. What's the lowest spot it reaches? Is this between 1 and -1? So I'm okay there. So I just simply sine inverse that guy, and I get 21.41 degrees. That is angle B. Do we know what to do here? Yeah. Now what we do is we go ahead and take 180 and we subtract 42 and we subtract 21.41 and we get 116.59. You'll be okay. You've seen it before. Your teacher showed it to you a couple of years ago. You'll be all right with it. Yep. So now, can somebody tell me what I do to figure out side C? Sine 42 over 22 equals? Good, 116.59 over C. Now we're going to focus on what Gavin said, is I am going to think really about the cross multiplying here. I get 22 sine of 116.59 is equal to C sine of 42. Very good, Hayden. Hayden says divide that sine of 42 off. Yep, you guys are doing a great job. So, I'm sorry, I thought Zelly had a question there. So 22 sine of 116.59, and I divide, remember, close my parenthesis, divided by sine 42. No, we've been there. I get 29.40. Was that a little bit review? Yeah, that's what we've learned so far. We've encountered those types of problems. I hope that was reviewed. The next two are just slightly different. What I want to ask you is, how do I again check my answer? Biggest angle, biggest side, smallest angle, small side. We all good there? Hey, we knocked it out of the park, right? So why do we have all these other options? Let's try one that's just a little bit different. Huh. Okay, do I know this side here? Do I know this side that I'm pointing to? Do I know this side? What is it? Very good. 25. So B is 25. Angle A is 85. And then we know side A here is 15. Okay, so which of the six cases is this? This is another side angle, isn't it? So we're back to donkey situation. We go down. Leslie's already seeing it. We look down here, and it's a side angle. The side is the side opposite angle longer or shorter than the other given side. Which one is it? It's shorter. If you look at here, side opposite the angle is 15. The other one's 25, so that's shorter. If it's shorter, I've got a tough deal here. Okay, I either, when solving for the missing angle, if sine is greater than 1, there's no solution. Or when solving, if sine of theta is less than 1, then there are two solutions. So we're going to either now, if you end up in this scenario, you either got no solution or two solutions. And you don't know which. You have to set it up. Let's set it up. Sine of what? 85 over 15. Sine of B over 25. Now, I want to solve for sine of B. So I just multiply both sides by 25 sine of 85 over 15 is equal to sine of B. So I'm going to plug that in, as my friend JJ so eloquently said. Thank you. And I get 1.66. Wait a minute. Whoa. What? Whoa. Why? Why? Give Morgan a round of applause. Folks, look at what we have. We have 1.66 is equal to the sine of b. You just told me the sine graph at most can be 1 and at least can be negative 1. So is 1.66 between 1 and negative 1? No. Watch what happens if you inverse this guy. Sine inverse the answer, and your calculator says problem. Okay? Yeah, if you hit go to, it's going to find where the error is. It says, I don't like what you're trying to sine inverse. That is not a good thing. Watch this. I'll try to sine inverse. We'll try 1.2 and see what it does. It doesn't like it. You press go to, it says, I don't like the 1.2. You know what? Let's try to, maybe we'll get really close. 1.0000. Oh, I got 2 points there. We'll put a 0 there, and we'll go put a 1 on the other. Maybe we can trick it. We'll get really close to 1. Press enter. Whoa! What? We'll try again. We'll go sine inverse. I'll go just below 1. I'll go like 0.9999999. See what we get there, and all of a sudden, hey, it's happy now. If you're above 1, it says forget it. Sine can only go up to 1. You guys see how trigonometry is connected? Do you understand why I taught you how to graph sine and cosine? It's to help prepare you for these other pieces. So it does make sense. So we got what here? We got no solution, baby. Done. Back up a page here to this spot right here. Right here. Okay? I want to show you what is actually happening in that situation. Draw that kind of shape. Okay? What kind of? I'll show you. I'll show you a sketch in a second. It'll make sense in just a second. As you set that up right there, look at that guy right there. Okay, everybody agree that side angle. Is the side opposite angle longer or shorter than the other given side? Shorter. Now suppose instead of 2, suppose I would have made this 8. Does that look like a realistic possible triangle? Yeah, but if you look, does it look possible that you could only have a length of 2? Looks like 2 is probably too short, isn't it? And in fact, that's what happened to our triangle. This side right here, it's like it wants to be pulled down front, but it just can't make it. It just can't reach the bottom there. It's only got length of 2. Just does not work. So this triangle that you guys just made over here, here's the problem. See how we got this 85 and this 25 and this 15? This 15 is just way too short. There's actually, it should only be about that one. It actually can't reach over to the other side. Now, if we would reduce this angle and make this like, say, 65, then maybe the 15 could reach it. But in fact, the 15 is just way too stinking short. Yeah. You can't until you figure out angle B. I mean, so you can't figure it out right now. You don't know where that lies. And so, you might be like there, and then again, you're trying to swing down to that spot. You can't. Maybe the distance goes all the way up there, won't swing over there. It just can't reach. No. Let's look at the last example here. Yeah, but these are, so do you guys like the no solution option? The first option we've done before, haven't we? The second option was no solution. Let's look at the third option here. I'm going to sketch this triangle again. That is 20.5 degrees. Got side A is 12. So I'll call, and then we'll call this B, we'll call this C. And then side B is a 31. What kind of triangle we got going on here? Side angle, okay? Side angle. That's what we're focusing on today. Flip back so I can show you this part of the notes. So this is another piece. You guys remember the other day in geometry you said, oh, I finally understand the difference between side angle and side angle side? Like, yeah, I wish I would have known that before. I'm gonna show you another thing like that right now. Hopefully this will make sense. We're gonna take this shape right here and call that 10. As Hayden said, we're gonna call it, say, 30 degrees. We don't know how long that is, but then we're gonna stretch one more length right here, and we're gonna call it a length of 8. Can somebody out there, as you draw this, this is the key moment of today. Everybody agree I have side-side angle? Okay, watch the problem here. That's a triangle. Does that look like a legitimate triangle that is 30 degrees, 10, and 8? Does that look like it's a decent construction? Watch what I could do to make another triangle that's also 8 by 10 by 30. I take this leg right here, and I simply just take it like a pendulum and swing it. Boom. Doesn't that look like it also has a side length of 8? And if I swing it back, there it has a length of 8 again. So the question is, which triangle is it talking about? Remember, in geometry, your teachers always said that side-side angle is bad, and you wondered why. This is why. You don't know which stinking triangle you're getting. Are you getting that one or this one? Now, here's the challenge. Look at this guy right here. Would you say that this angle right here is acute or obtuse? Do you remember the difference between, what does acute mean? Yeah, so this is acute, right? Yeah, so everybody agree that that one's acute? Now watch this. If I swing it over here, that angle is obtuse. So the fact is, there's two triangles. One's got an acute angle, one's got an obtuse angle. Let's see how that comes up. We flip to our last example. Here's our triangle. Side opposite longer or shorter than the other given side? It's shorter. As I look at my decision tree, I'm at side angle. I go down. It's the side opposite angle shorter than the other given side. So I either have no solution or I have two solutions. We don't know until we set it up. Everybody usually says, Gens, how do I know? Just tell me from the beginning. So you got to set it up. Sine of what? 20.5 over 12 is equal to B over 31. Do I need to cross multiply, or do I just need to multiply both sides by something? By what? 31 sine of 20.5 over 12 is equal to sine of B. Okay, I'm going to type that in, see what I get. 31 sine of 20.5 divided by 12. And I get 0.9. Can sine have a value of 0.9? Is that between 1 and negative 1? So now I know in this situation, I for sure got two solutions. So you need to make triangle 1. You need to make triangle 2. A, B, C, A, B, C. A, B, C, A, B, C. When you run into one on the test, you're going to be able to do it because you're smart. You're going to work to your potential. All right. Which ones do you think are the same here? Okay. What is angle A? What's angle A? So I put 20.5 degrees for each one. 20.5 degrees. Okay. All right. Thank you. I appreciate that. Can you slow down so I can make my marks? Yeah. What else do we know, JJ? Yep. So put 12 for little a. 31 for little b. Now, you guys remember my drawing? I drew two triangles. One was an acute angle. The other one was obtuse. So what we're going to do right now is you came up with sine of B. Sine of B was equal to like 0.9 something, right? So here's where everybody gets confused. Once we've got this, we just go sine inverse, and I get 64.78. Is that the acute or the obtuse? That's the acute. Do you know how I find the obtuse? All I do is just subtract 180. 180 minus 64.78. You do. Before we do that, because I know you guys know how to do that, I gotta make this last connection so you can see why it works out. You guys saw acute and obtuse, right? Remember when you guys remember your last test, you guys did so well with this. You said sine of theta was equal to 0.9. And we solved that on our test, right? And you said, oh, sine's positive. In which quadrants was sine positive? First and second, right? There's positive there and there. And then what did you do to find those spots? You did inverse, right? And when you inverse, you got 64.78. 64.78. That was the acute one. The obtuse one is that stinking one right there. You see how it's all connected? That's the beauty of trigonometry. It's all connected together. We've done it before. There's no trick. Thank you. That's the beauty of mathematics and the connectedness and why I love it. It's all connected. It's not like somebody made it up. It's all there. It's all connected. So let's go to JJL's point. Now that you have these, you can just solve them. Okay, you just use this one and move back and forth. JJL, how do we find this angle C? So I got 180 minus 20.5 minus 64.78. I get 94.72. I'm not going to make you draw it. You just got to find them. Could I then find side C? How? Sine of? Let's take the one that we know. You're right. I'm going to use 94. Let's take one that we know. 20.5 over what? 12 is equal to sine of 94.72 over C. I cross multiply and I get C sine of 20.5 equal 12 sine 94.72. How do I solve for that? Divide both sides by sine of 20.5. So 12 sine 94.72 divided by sine of 20.5, and I get 34.15. Does that make sense? It should be my biggest side. Yeah, that's the biggest angle, right? So 34.15. So that finished off triangle 1. Can we finish off triangle 2? How do we do that? Minus 20.5 minus 115.22. We get 44.28. Pythagorean theorem? Why? Every triangle. Set up the law of sines. Sine 20.5 over 12 equals sine of 44.28 over C. Instead of writing it all out, I hope that by doing the law of sines, you guys have kind of caught on to it. It looks like I'm going to multiply these two, and I'm going to divide by this one, right? So 12 sine of 44.28 divided by sine of 20.5. And I get 24.14. Does it make sense that that's not my longest side? Yeah, it does. Good job. You guys are going to be way ahead for where we're going to be on Monday. You know, and people aren't here. Obviously, they're going to kind of see us again, right? And so I need to come up with kind of two lessons, one where you guys can kind of practice what we've done, and then one where I can kind of instruct others on and get us on the same page. So no solution, one solution, or two solutions. That's why we say that donkey causes so many problems. And that's why it was an issue when you guys were in. Yeah, donkey because ASS. Very good. Yep. Sorry. Sometimes don't know the jokes I'm making. Nice job. Enjoy your weekend. Oh, should we put a? I wonder. Do you think anybody will watch the video that's not here today? How about we put a code word in it, like I don't know, like pomegranate or something. Well, what's it, some word that they if they watch video, then they share it to me. Yeah, what's the word? We're getting the word avocado. Avocado. Come and say avocado, you get a free treat from Mr. Gibbs. There you go.